Hi, it's David, Ask the Electrician, and today we're going to take a look at how to wire receptacle outlets, 120 volt, 15 amp, and 20 amp receptacle outlets. And in this video we're going to be covering the outlets found in newer homes, the grounded outlets, and covering the back wiring and the side wiring. We're going to also be looking at the older home receptacles, what to do about ungrounded outlets, and we're going to be taking a look at stripping wire, pigtailing wiring, and testing the ground wire. And this is just a reminder that you can find this and a lot more information covered at asktheelectrician.com and also in my best-selling book about home electrical wiring. It's all available for you at asktheelectrician.com. And before we start any electrical wiring project, we always make sure that the circuit has been identified and turned off using a plug-in tester, electrical tester of any type, and then we identify the circuit breaker at the panel, turn it off, and post a note that work is being done on the circuit. And we're going to be taking a look at two different types of receptacle outlets, 120 volt, 125 volt, and the same thing. We have the standard type receptacle, and then we'll have the decorative style receptacle. They look a little bit different in the appearance, but they're basically the same characteristic as far as the voltage and the amperage. Okay, that being said, we do have two different amperages of a typical 120 volt receptacle outlet. We have the 15 amp, which is commonly found in bedrooms, living rooms, and hallways, and then we have the 20 amp, which may be found in kitchens, garages, and other locations like that. And not all receptacles are exactly the same when it comes to attaching the wires. With these examples here, we're seeing that there's push-in connectors or there's screw terminal connectors. Some receptacles, depending on the amperage, may only have the screw terminal connection only. To identify the voltage and amperage of the receptacle outlet, you can see this information stamped on the face of the outlet. In this example, it shows 15 amp 125 volt or 20 amp 125 volt. These receptacles are different in their characteristic. Okay, looking at the back of the receptacles, many of the features that are also stamped into the back showing the insulation strip gauge for the wire and how much insulation would be removed if the wire will be inserted into the push-in connection on the back of the receptacle. You can also see where there's a slot that you can insert a small screwdriver into and push to release any of the wire that might be already into the receptacle that needs to be removed. This applies to 15 amp 120 volt receptacles with number 14 solid copper wire only. And so these features are available typically on the 15 amp receptacle outlet, which can be used for back wiring with the push-in connections or side wiring with the screw terminals. And of course we have the green ground screw for the ground wire. The side terminals, the silver side is for the neutral wires, and the brass screws are for the power wires, the hot wires from the receptacle circuit. Okay, the 20 amp receptacle outlet is pretty much the same, except for it has a different configuration with the prong on the neutral side of the receptacle is going horizontally. The screw terminals are pretty much the same. The silver screws are for the neutral wires, and the brass screws are for the circuit hot wires. You'll notice on the back of the receptacle there is not a push-in back wiring capability for these. These receptacles are, for 20 amps, so they're a little bit more heavy duty. Now with the decorative style receptacle outlet, it's pretty much the same. It just has a little bit of a different appearance on the front, the face of it. But on the back side, with this 15 amp receptacle, it is basically the same as a standard duplex receptacle. It has the push-in connection capability and the side wire connection capability. The screw configurations are the same. The silver side is for the neutral wire, the brass side is for the hot wire of the circuit, and the green ground screw, of course, is for the ground wire. And of course, the best tool that we can use for wiring receptacle outlets is a really good pair of wire strippers, which has the built-in wire stripping gauge on the wire stripper pliers, which enables you to strip off the amount of insulation that you need to make up your connection on the back wire or the side wire. It also gives you the capability of putting the bare wire that you've stripped into a hole on the wire strippers and making your hook that you can use for connecting onto the side wire screw terminals. It's very, very handy. Makes a really good, nice, neat connection when you're using a really good tool like this. Now when we're making up the wires on the screw terminals for the side wire configuration, we make sure that the hook of the wire is going in the clockwise orientation so that it is screwed down and tightened directly under the screw, and it tightens up nicely as the screw is tightened in the clockwise rotation. Okay, and one of the easiest ways to replace a receptacle outlet is when we discover that there's only one cable coming into the outlet box. We have just one wire for the white, the black, and the green ground, or a bare ground wire. And so we determine in this case we're going to do a push-in back wire connection. So we strip out our wires appropriately. The right length of insulation is removed. We put the white wire on the silver side of the receptacle, the black wire on the brass side of the receptacle, and the green ground wire goes on the ground screw, the green ground screw. And we double check and make sure that those back wire connections are in really good and tight. They won't come back out, they won't pull back out when we give it a little tug test. And then we mount our receptacle into the outlet box, put our cover on, and we're done with that one. Now in some cases we find that we have more than one cable coming into the outlet box. In this case we have two cables coming in, so we have two white wires, two black wires, and two ground wires. In this case we have one bare ground wire that has been junctioned and pigtailed to the other ground wire. This splice has been made up and it is in the back of the outlet box already. So we prepare our wires. We put a hook on the ground wire, the bare ground wire, and we prepare and strip back the other wires that will be used for a push-in connection using the push-in back-wired method for this particular receptacle outlet. So we're being very careful to make sure that our insulation is stripped off of each wire appropriately to the right length. They're inserted all the way into the back wire connection holes on the receptacles and on the right side. The black hot wires, the black wires on the brass side, the white wires on the silver side of the screw terminals, and the bare ground wire goes to, of course, the green ground screw. Okay, let's look at another situation where we have two sets of cables coming into an outlet box. We have two whites, two blacks, and we have a bare ground wire. It's already been pigtailed out, so we're making a hook on the bare ground wire, but we're going to make up this receptacle with the side wiring, not the back wiring. So we're going to be making up the wires to the screw terminals, so we still have to remove an appropriate amount of insulation, right around 1 inch, and we're making a hook on each of the bare stripped out wires. We're putting the green ground, the bare ground wire on the green ground screw, and then we are going to go ahead and attach the white wires to the silver screws on the one side, and then the black wires on the brass screws on the opposite side. Once this is done, we make sure we're doing this with the wires facing in the clockwise rotation orientation, and then we are going to be screwing down and tightening our screw terminals snugly down, really nice, with all of these connections, making sure that they're really good and tight. And we'll button up this receptacle, put on the cover plate, and we're done with that. Now, up until this point, we've attached all of the wires to the receptacle outlets, whether they're back wired on the back push-in method or side wiring using the screw terminals. But with this one here, we're going to do something a little bit differently. You can see how this can be quite messy with some of the receptacles that we find out in the field. They're really, really overwired. And so what we really prefer to do is to make a pigtail splice. And we're going to show you how to do that right here. Step 1, we prepare the wires. Step 2, we strip them out, we twist them together, and then we go ahead and we add the wire connector with a pigtail wire, a single wire that's attached to the white wires for the neutral wires, the black wires for the power wires, and the ground wire. Now, the reason why this is the preferred method is because the load of the electrical circuit is not passing through the outlet. And what that means is that when the wires are attached to either the back side on the push-in method or the side wires, and they're not pigtailed, the load, the electrical load of the whole circuit passes through each one of those receptacle outlets. And if there is a space heater or an air conditioner that is on that circuit, let's say it's at the end of the circuit and it's a bedroom outlet circuit, those receptacle outlets can actually get warm and hot, and it could cause them to burn out. It could be a hazardous situation. But, you know, again, these are UL approved receptacles. The configurations and the wiring methods are available and capable of wiring it either way. But when we do find that people are using space heaters and air conditioners in a room like this, we always wire it with a pigtail configuration, and we only attach the one single pigtail to the receptacle outlet, not all of the wires. So we are splicing the wires, the circuit wires, into the outlet receptacle box. So we only come out to the receptacle with one wire. And again, if we know that it's a load for an air conditioner or a space heater, a small space heater, then we'll make it up on the side wiring with the side screw terminals, not the back push-in wiring. In most cases, though, it depends on the size of the air conditioner and the space heater. These items should have a dedicated circuit run to them, and this will prevent overloading a circuit and causing a situation which could overheat the wiring, overheat the receptacle outlets, and create a hazardous situation. And so here we have an example of multiple problems. First of all, this is not pigtailed wiring at all. We've got 3 cables coming into this receptacle box. This is a GFCI outlet, which, you know, it's the same thing as an outlet except for it has GFI protection. It does have the feed-through capability, but you'll notice there is no pigtail wiring on one of the sides, whether it's the line or the load side of this receptacle. We've got multiple wires being connected to this outlet, and of course it's been overheated. You can see where the insulation is burning back, and this is an example where if there was pigtail wiring and it was wired properly, then we wouldn't have this overheated and hazardous situation. So we go back to the pigtail wiring situation, and this is a method that can be done whether there's 2 cables coming into the outlet box, 3 cables coming into it, whatever the case might be. We pigtail all of these wires together of the same color, okay, whites to whites, blacks to blacks, bare ground wires to ground wires. We make these splices with the single pigtail coming out, which will then be connected to your receptacle outlet. And this will alleviate the problem of the circuit load being run and flowing through each individual outlet on that circuit. So what about an older home? Is there a ground wire? You might open up the outlet box to replace the receptacle and see that there's only 2 wires. And there isn't a ground wire, just a black and a white. And you might think about replacing the outlet with a 3-prong or 3-wire outlet. But is that going to be the right thing to do? Will there really be a ground to that outlet if you replace it with a 3-prong outlet? Will it really be grounded? Well, let's talk about this. If there is no ground wire, there won't be a path to a ground source. And so that ground prong would actually be a false ground. It won't work at all as a ground. So if there is no ground wire, we do not want to install a 3-wire receptacle with a ground prong, because the ground prong is not connected to a ground source or to the earth ground. So we go ahead and we install a 2-wire receptacle. Okay, now let's take a look at some of these older receptacles, the 2-wire receptacles, and take a look at a surprise that we sometimes run into. We will see an old 2-wire, 2-prong receptacle outlet that has been installed. There is no ground prong, there is no ground screw to attach a ground wire to, but lo and behold, we do run into a situation where the wiring may have been updated and there actually is a ground wire, but the ground wire, of course, has not been attached to the receptacle outlet. So what do? The first thing we want to do is we want to test the ground wire and see if it actually goes somewhere. And of course, it has to lead back to the panel and back to the grounding, electric grounding system at the main panel or the sub panel, whichever is feeding the outlet circuit. Now, once we've verified that the ground system is intact and is installed in the home, and in some cases, such as this, where there was a kitchen remodel project, we discovered that the old method of grounding was intact, where they bring the ground wires together inside the wall, twisting the ground wires together, sometimes putting the ground wire up into the box, but sometimes just going on into the other areas where the branch circuit goes to in the other outlet areas. So we perform our upgrades, and along with that, we install a green ground screw. We bond that to the metal box, create a pigtail to go out to the receptacle outlet, and we're bringing that portion of the system up to code and up to date. Now again, part of the verification of the ground system is typically done by a qualified electrician, and we definitely check at the main panel and the sub panels if that's the case to verify that the ground system is installed and the ground wiring is attached to the ground terminals as required. Okay, so let's review this really fast. Is there a ground wire? If not, then install a 2-wire outlet. Don't take a chance. Go ahead and install a 2-wire outlet. But if there is a ground wire and it has been verified, then go ahead and install the 3-wire duplex receptacle with a ground prong and be sure to connect the ground wire. So be sure to visit me at asktheelectrician.com. Pick up your free downloadable 10 mistakes and how to avoid them ebook, and register for my free newsletter that comes out every week, Electrical Tips newsletter. There's a lot for you at the website, a lot of questions and answers and pictorial tutorials of a lot of electrical projects around your home. Look forward to seeing you there, and don't forget, let your light shine.